Hello, this is Lab 1 of Physics 2212, named Charged Tapes by John Cutrone. Some goals of this experiment are to electrically charge two pieces of clear tape, observe the interactions between the charged tape and other objects, quantify the amount of excess charge on one piece of charged tape, and to create an accurate simulation of the electric and gravitational forces. Some of the findings of this experiment are that the electrically charged tape possesses a negative net charge of negative 2.66 times 10 to the negative 9th coulombs, and the ratio between the excess electrons and atoms found on the tape is 4.84 times 10 to the negative 8. Some main physics concepts explored are Newton's second law of force equals mass times acceleration in the form of gravitational force, and Coulomb's law, which is the electrical force equals the constant times the two charges divided by the separation distance squared. In addition, the net force is seen to be the electric force plus the gravitational force equals 0 at equilibrium. The procedure is to prepare the two charged tapes by applying a base tape on the flat surface and pulling another piece of tape off of it to charge it. An observation of the interaction between two charged U-tapes should be made, in addition to an observation of the interaction between a U-tape and a negatively charged pen. Finally, a U-tape should be suspended on two objects of equal height, and another U-tape should be placed under it to see the resulting interaction, i.e. finding separation distance. Some observations from the experiment are that the two U-tapes repelled each other when brought together, and the U-tape and the negatively charged pen were repelled, which signifies that the U-tape is negatively charged because like charges repel. In addition, the suspended U-tape and the held U-tape repelled each other at a separation distance of 0.006 meters. Some assumptions of a model are that the air resistance can be ignored, the sum of charges on the long tape can be represented by a point charge at its center, and both U-tapes have the same amount of charge evenly distributed along their respective lengths. This is a basic system and surroundings model of the two pieces of tape. The red particle represents the top tape, which is the system, and the blue particle represents the bottom tape, which is the surroundings. The yellow arrows represent electric force, the green arrow represents gravitational force, and the orange arrow represents normal force. Some experimental calculations that were made are the surface area of the tape, the surface area of an atom, which is used to find the total number of atoms on the piece of tape, which is found from the length, the width, and the mass of tape, as well as the separation. The gravitational force on the U-tape is found by multiplying mass times gravity, and the electric force is therefore found because the force of gravity and the electric forces are equal and opposite of each other, which will allow us to find the charge of each tape by plugging in all the numbers in the electric force equation and knowing that Q1 equals Q2. Finally, the number of excess electrons are calculated by dividing the charge of the tape by the average charge of an electron, and the ratio between excess electrons and atoms on the tape is found by dividing the number of electrons by the number of. The Python code constants all show different values that I discussed. In addition, the Python code calculations all have different equations that basically equate to the calculations I here. The data versus model predictions, the code data model versus the model that I showed earlier are basically the same. The model prediction just shows more of the forces through different arrows, but they represent the same phenomenon. Some discussion questions are, what if electrons had positive charge and protons had negative charge? What would change about the observations you would make with the tape and the other charged objects? The answer is that if they switch charges, nothing would change, as like charges would still repel each other, but the electric field vectors would switch sides. And why is it important to handle the charged tape as little as possible? What happens when the tapes come into contact with your hands? The answer is that electrons can transfer between the tape in your hands, which will reduce its electric. Possible sources of error are due to measurement and alignment errors that are pretty small. The conclusion is that opposite charges attract and like charges repel, and objects can become charged through interaction of other objects, and objects held in equilibrium open up new opportunities for calculations. Thank you.